Welcome back, ladies and gentlemen. We're into 2.1, Day 2, Graphing Equations using an XY chart. Now, the objective for today is to graph these equations that are not already in y equals form. Okay, what we have here on the screen is basically just a summary of the previous lesson's rules. We're going to pick several x values and put them in the chart. We're going to plug those values and solve for y, plot them on the graph, and then draw a line on the points. And again, it should not curve. Alright, let's start putting this to use. Alrighty, take a look at what we have here. We want to graph the equation 4x plus 3y equals 6. Alright, so again, okay, notice the y is not by itself. We have a lot of stuff on the other side with it. It's going to cause a complication, but here we go. Let's dive into it. Okay, again, first thing first, I'm going to pick a 0 for x because that's an easy number to put in. So I'm going to have now 4 times 0 plus 3y equals 6. Okay, now this is a little bit different than the previous lesson because we have stuff on both sides of the equal sign instead of just the y. Okay, now conveniently 4 times 0 is just 0, and I confess I probably wouldn't have written that 0 ever, because really if you have 0 plus anything, it's just that anything. So realistically, I probably should have just gone to the 3y equals 6. Okay, but at this point we just divide through by 3, and we get y equals 2. Alright, so that goes in my chart. So that now has 1 point, I need 2 more. So let's pick 1 for x, and put a line to separate things. So I'm going to go 4 times 1 plus 3y equals 6. And as I go through the process again, 4 plus 3 equals 6. Again, I notice this time I don't have something that just cancels itself off, so now I'm going to subtract both sides by 4. Have a 3y equals now 6 minus 4 is going to be a 2. And now dividing through by the 3 gives me 2/3. Kind of an icky number, but it's what we have. Okay, and I'm a little cramped for space, so hopefully when I pick a 2, I can have something come out nice here. 4 times 2 plus 3y equals 6. I'll put a little line here to separate everything that's going on. That becomes an 8 plus 3y equals 6. Again, I'm now subtracting 8 from both sides, giving me a 3y equals negative 2. Dividing through by the 3 now gives me y equals negative 2/3. Okay, so basically the really bad news about what we just did is we generated a lot of fractiony sort of points. We can deal with those, but it's not as much fun as having nice whole number kind of things. But anyway, 0, 2, and then I've got 1 and then 2/3. Put us right about there. 2/3 is a little more than halfway to the next one. And then 2, I go down 2/3. So if I'm going down 2/3, that's almost down to the negative 1, but not quite. Again, notice that we do have all 3 of those dots in a straight line, so I feel pretty good about life in general. And, well, I could have drawn that a little bit better, but there you go. Pretend I hit that other dot. So there's how you do that way. Alright, well, you may have thought that was a lot of work, and I'd agree with you, but fortunately, there's another way. Okay, basically, we can rewrite our equations into y equals 4. We're going to save ourselves a lot of heartache and misery that we had to do on that last problem. And we're going to have another little benefit from it, but we'll get to that later. Okay, well, first thing we want to do is we want to either add or subtract. Okay, we're going to eliminate the x term from the left side, and make sure you don't combine unlike terms during this step. That's a mistake that people tend to make a lot. Okay, once we've done that, we should have something y equals some other stuff on the other side. So basically what we're going to do is divide both sides of the equation by the y term's coefficient. Okay, now coefficient is a big fancy word, but all that means it's the number in front of the y. Okay, so in case coefficient doesn't make sense, that's the number in front. Alright, so we're going to be dividing by the number in front of the y, and a little bit of fanciness here, we're going to have to divide every term on both sides, and this is one case where fractions are much better than decimals. But anyway, at this point you should be able to graph the new equation like we did in the previous lesson. Okay, so let's see how that looks. Alright, so I'm being asked to graph this equation again, but I don't want to have to go through plugging in values here, solving by doing all my equation solving stuff, and then potentially ending up with some fractiony values. So I'm going to see if I can avoid that by doing those steps from the previous slide. And here they are. So I've got a positive 4x, so again I'm going to either add or subtract to cancel them out, and so in this case, since he's a positive 4x, I'm subtracting to cancel him. So he's gone. So now I've got a 3y on the left, and then over here, now this is what I meant by the unlike terms. This is a positive 6 without an x, and this is a negative 4 with an x. So they aren't like terms at all, so you can't do anything more than just basically list them as 2 separate pieces. Okay, now the equation I'm looking for usually is going to have the x first and the other regular number second, so I'm going to purposely write the negative 4x first, and this is a positive 6, so I'll bring the positive 6 down, but again, since he was positive, I'll put a plus sign there. Okay, at this point, I've got this 3 that's in front of my y, and I want to get rid of him, so I'm going to divide both sides by 3, and as it said, I want to divide everybody by 3. Okay, if you want, please ask in class, and I'll explain why it's necessary to do everything. I just didn't want to make the video longer by spending a lot of time on it now. Alright, but that being said, the 3's cancel. I've got negative 4/3 that doesn't reduce, so I'm going to leave it as negative 4/3. And then I've got 6 over 3, well that does reduce, and it becomes a 2. Okay, now what I've got here is a much nicer equation. I'm going to circle it, not because it's a final answer, but it's just something that's really, really nice to have. Alright, now remember from our previous lesson, I want to graph this guy. I've got a denominator of 3, so I'm now pick multiples of 3. Okay, the nicest multiple of 3 is 0 for our purposes, and then 3 and then 6 are other good ones. Again, you might have thought negative 3 or possibly 9 is other good ones, which would be great. Those are just the ones I would like to use now. Alright, so again, plugging those in, we get y equals negative 4/3 times 0 plus 2. Okay, I love plugging in 0 because it just cancels stuff out. So really all I'm left with is a 2. Bring it over there in my chart. And let's keep going. So negative 4/3 times 3 plus 2. Again, if you're good with a calculator, you can type that all at once, or if you're good with mental math, you can do it all in your head. But here we go, these 3's will cancel, leaving us with a negative 4, and negative 4 plus 2 is negative 2. Alright, and then finally with the 6, negative 4/3 times 6 plus 2. Okay, the 3 and the 6 reduce down to a 2. Negative 4 and the 2 give me an 8. Negative 8 and 2 give me a negative 6. Alright, so there's my 3 points. Notice this is a little bit less work than we had to do in that other thing, but really it's up to you. But I'm going to plot 0, 2, and I plot 3, negative 2, lands me right there. And then I plot 6, 1, 2, 3, 4, 5, 6, negative 6, 1, 2, 3, 4, 5, 6, I think. Alright, hopefully I didn't miscount right there. And again, those 3 look like they line up pretty darn well, so I'm going to draw my line through there, feeling pretty good about life in general. And there you go. Okay, now if you flip back in your notes, this line should look just like the one from the other example, except that it's a little bit longer, if you will, but remember it goes infinitely in both directions, so it's not really a question of longer. But the other points I had in that other problem were right about there and right about there. So notice I do get 2 points on the same line. It was just same equation here from the previous example gave me the same line. Just by doing it this way, I was able to avoid fractions altogether. So that's why I personally think this is a really nice thing to be able to do if you're going about graphing lines. Alright, well the new thing about this lesson is getting the equations into y equals form, so let's practice a couple of those. Alright, so this first guy, 4x plus 7y equals 14, this is I suppose the nicer of the two. If you look at the other guy, he's got a bunch of negatives in him. But again, first thing I want to do is subtract or add whatever it takes to cancel the x term. So I'm going to do that to both sides here. Again, remember both sides of the equal sign, so if it helps you to kind of draw in that little separator, please do. But whatever the case, the 4x's cancel, leaving with a 7y on the left. I got my equal sign. And then again, 14 and negative 4x are not like terms, so please don't even think about putting those guys together. Simply write as a negative 4x and then a positive 14. Okay, now again, I've got that 7 that I want to get rid of, so in this case I'll have to divide it because it is multiplied 7 times y, so I'm dividing everybody by 7 now. And I've got the y by itself, so I'm really super happy. 4/7 does not reduce, so I'm going to leave that as negative 4/7, throw the x on there, and then 14 over 7 does reduce to a 2. And there we go. So that's what that equation will look like, and then again, if you wanted to graph it, you go ahead about picking multiples of 7, so 0, 7, and 14, or something like that. Alright, moving along to this guy. Okay, now I've got a negative 6x, so don't freak out with that, just think, hey, I still have to cancel them. And so in this case, it's a positive 6x that I'm going to use to cancel them out. Okay, again, if it helps you to have that little separator in there, put that in. And now I've got a positive 6x. Okay, those guys cancel, that was a point. Make sure you bring down the negative here, so that's a negative 5y. Got our equal sign, and now again, I've got a x term and a not x term, so I can't put them together. So I just have 6x plus 40. And then I'm dividing. Now notice how I'm going to be dividing by a negative in this case, which is going to have some implications here on the other side. So a negative 5 for everybody. Okay, so again, y is down by himself. Okay, 6 over negative 5 doesn't reduce. Although one quirky little thing, it's really nicer to have a negative sign on top. But if you think about it, it's one positive, one negative, so it's a negative anyway. So it is equivalent and actually better form that if you have one negative in a fraction that you put them on the top. So it is negative 6/5 x, and then I've got a positive 40 over negative 5. Well, if I divide those, I get a negative 8. And so again, there would be our equation in a much nicer form for doing graphing. Alright, at this point I'd like to just demonstrate one more, and then cut you loose on a couple of the try these type problems. But here we go. Okay, I've got 4x minus 3y equals negative 9. Okay, again, I want to get rid of whatever that x term is, so I'm going to subtract 4x from both sides first, because it's a positive 4x. I subtract and cancel them out. Okay, again, I get a negative 3y coming down. Okay, then I've got my equal sign. Then again, not like terms, so I'm going to list my negative 4x first and my negative 9 second. And it's just nice to have it in that order, I think. Okay, now again, I have to divide off the y coefficient. So in this case, it's negative 3, so I divide him and every other term by negative 3. Okay, now watch out, we got lots of negative signs here, so be careful. Okay, negative 3 over negative 3 cancels out to be a positive 1y. Again, I don't bother writing that 1 in there. But now I've got a negative 4 over negative 3. And hey, anytime you're dividing and have two negatives make a positive. So even though the fraction itself doesn't reduce, the two negatives do cancel each other out. Okay, again, I've got that x still kind of hanging loose. And then I've got a negative 9 over negative 3. Again, two negatives I'm dividing becomes a positive, and 9 divided by 3 is 3. Okay, so again, I've got this nice little equation. Okay, so I start picking some x values. Okay, again, 0 is always a good one. And again, I have a 3 denominator, so I'm going to pick multiples of 3 again. So that's 3 and 6. And then let's start going. Okay, plug in the 0. Again, hopefully, after a little bit of practice with this, you can do this a lot quicker than what I'm about to do, but 4/3 times 0 is 0. 0 plus 3 is 3. Alright, plugging in the 3. 4/3 times 3 plus 3. It's a lot of 3's, don't get confused by them all. 3's cancel, and then 4 plus 3 gives me a 7. Alright, now I'm going to run into a little bit of problem here, and I did that on purpose so I could demonstrate what you can do if you do run into problems, but here we go. 4/3 times 6 plus 3 equals, okay, if this cancels down to a 2, the 3 and the 6, then we have 4 times the 2 that's left over gives me 8, and 8 plus 3 is 11. And that guy is a little bit on the big side. So, oops, I forgot the 7 over there, but the 11 is kind of big. So if you get a number that's too big, what you can do is just pick a number maybe in the other direction. So 6, 3, 0, another multiple of 3. If I go to the negative side, I can pick a negative 3. And now 4/3 times negative 3 plus 3. Alright. Now the 3 and the negative 3 sort of cancel, but it does leave a negative 1. So I have 4 times negative 1, which is negative 4, and then negative 4 plus the 3 that's over here is going to give me a negative 1, which is going to be a lot more user-friendly as far as fitting on the graph that I have. Okay, so here we go. 0, 3, 1, 2, 3, nice pretty dot. 3, 7, 1, 2, 3, 4, 5, 6, 7. Okay, then again, if I tried 6, 11, I'd end up being way here off the map almost, so I'm going to kind of skip that guy and just go negative 3, negative 1, negative 3, negative 1, goes about right there. And again, looking at my dots, they seem to line up pretty well. So I'm going to draw, oof, that was a pretty wicked curve on that line, but there we go. If you imagine well, hopefully you can kind of tell those go straight. And that's what that guy looked like. Alrighty, now, as promised in the previous slide, here's the first try these problem. And here's the second one. Okay, don't let the x by itself mess you up there. Remember, it is really just a 1x, so please do handle that accordingly when you do this problem. Alright, and I'll see you guys in class.